Hi students, welcome back to the online classes. So this is the third session of the chapter learning how to measure. So till now we have seen how we will measure the lengths. Now we are explaining about areas. We are explaining about areas. What is an area? Area is the measure of extent of plane surface occupied by an object. So area is nothing but extent of space occupied by an object. For example, I have found an object, I have considered an object. So if you place this object on a plane, it will occupy some place. What is the place occupied by this object? So this is the place occupied by this object. So we will call this as area of this object. So area is the measure of space occupied by an object on a plane surface. So let us see, I will draw two areas. So I will draw two areas. So this is area, this is sheet A. I had two sheets, one is sheet A and another one is sheet B. So this is sheet A and this is sheet B. So can you compare these two? Among these two, which sheet? I have sheet A, this is sheet A, this is sheet B. So among these two, which sheet is larger? To identify which is larger one, we need to measure the area. We need to measure how much place it was occupied, how much place it will occupied. So it appears to be, it is not easy to identify whether which is larger and which is smaller. So we need some measurement. We need to measure the area occupied by this sheet. We need to measure the area occupied by these sheets for the comparisons. So we need some measurements. So this is this type of measurement. So this sheet occupies some place on the plane surface. On a plane surface, it occupied some place. That measure is called as area. So how can we measure the area? So do you know about what is 1 centimeter? Yes, we learned about 1 centimeter of length. So in your scale from 0 to 1, if you draw a line from 0 to 1, then this line indicates 1 centimeter. Using your scale, you can draw a 1 centimeter of line. So using that 1 centimeter of line, I have drawn a 1 centimeter of line. So using this line, using 1 centimeter of line, construct a square. A square is a geometrical shape which is having all sides are equal. So this is 1 centimeter, this is 1 centimeter of length, and this side is 1 centimeter, this is 1 centimeter. What we call this shape? We will call this as square. And the area of this square is 1 square centimeter. 1 square centimeter. So 1 square centimeter is the square obtained by using 1 centimeter of line. 1 square centimeter. So what is 1 square centimeter? So it is the square obtained by the line of 1 centimeter. So it is the square having each side 1 centimeter. 1 square centimeter. What that means? A square having each side as 1 centimeter. A square of side 1 centimeter is the 1 square centimeter. What is the area of this square? It is 1 square centimeter. It is a square. Centimeter square. 1 square centimeter. So in mathematically we can write this as 1 centimeter square. Mathematically you have to write as 1 centimeter square. 1 centimeter square. You have to denote square in the power, as the power. 1 centimeter square means here square indicates, for example, so what is, if you construct a square with 1 centimeter of length, if you construct a square with 1 centimeter of length, then this area is 1 centimeter square. 1 centimeter square. So what is 1 centimeter square? What is this power indicates? For example, if there is 2 plus 2, you can write 2 into 2. 2 plus 2 plus 2 is equal to 3 into 2. So 2 plus 2 plus 2 plus 2, that is equal to, how many 2's are there? 1, 2, 3, 4. So 4 into 2. For example, if there is another 2 is also there. How many 2's are there? 5. So 5 into 2, the summation is 5 into 2 is equal to 10. Here 3 2's are there. So if there is a summation, you have to write 3 beside to it. But if there is multiplication, so if there is multiplication, 2 into 2 is there, then it is equal to, if there is multiplication, it is equal to 2 square. 2 square. If there is 2 into 2 into 2, so you have to write 2 cube. This is nothing but 2 cube. In the shortest form we are writing. So how many times you have to write? 3. So to avoid that, to avoid this long form, you can write simply 2 cube. So if there are 2 into 2 into 2 into 2 into 2, so you can write shortly this as 2 power 5. How many 5s? How many 2's are there? 1, 2, 3, 4, 5. 5 2's are there. Hence you can write 2 power 5. So this is the meaning of power. 2 power 5. So here similarly, 1 centimeter square is equal to 1 centimeter square is equal to 1 centimeter square means centimeter into centimeter. Centimeter into centimeter. So this is the meaning of this power square. So a square which is formed with 1 centimeter of length is called area having 1 centimeter square. What is the area of this square? 1 centimeter square. So let us divide this complete sheet. Let us divide this complete sheet into 1 centimeter square boxes. Divide this complete area. Divide this complete area into 1 centimeter square boxes. So let us divide this. 1, 2, 3, 4, enough. So let us assume that I was divided. So each box area is 1 centimeter square. Each box area is 1 centimeter square. So I was divided the complete area into 1 centimeter square boxes. This is 1 centimeter, this is 1 centimeter. So I have divided the complete sheet A into some boxes. Each box is 1 centimeter square. So 1 plus 1, 2. How many boxes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the area is, so what is the total area? 1 centimeter square plus 1 centimeter. How many 1 centimeter squares are there? 22. So we can write the area of this sheet A is 22 centimeter square. 22 centimeter square. What this indicates? This indicates, you can write this as 22 into 1 centimeter square. You can write this 22 centimeter square as 22 into 1 centimeter square. How many 1 centimeter square boxes are there? 22 are there. That's why the area of the sheet is 22 centimeter square. How many 1 centimeter square boxes are there? 22 are there. So that's why we can say that it as 22 centimeter square. So let us find out this area also. Let us divide like this. So let us count how many boxes are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 1 centimeter square boxes are there. You have to divide the sheet area using scale only, by measuring 1 centimeter 1 centimeter. You cannot divide like that. I was just explaining only. You have to use scale to divide the sheet into boxes. So let us see how many boxes you have got. 18 centimeter square. So you have got total 18 boxes. That's why it is the area of this sheet is 18 centimeter square. What this indicates? You can write this as 18 into 1, 18 only. Centimeter square remains here. So how many 1 centimeter square boxes are there? 18 are there, and hence the area of this sheet is 18 centimeter square. 18 centimeter square. So this is about area. We can measure the area by taking 1 centimeter square as a standard unit. Standard unit. 1 centimeter square is as a standard unit of area. So similar to 1 centimeter square, you can measure the area in 1 meter square also. You can measure the area in 1 millimeter square also. 1 millimeter square, 1 centimeter square, 1 meter square are the units of area. So this is the concept of area. So let us discuss another example. There are some formulas to find area. For example, there will be some formulas for different shapes to find the areas. So let us consider a rectangle. This is a rectangle. So this is a rectangle of length 3 centimeters. This is a rectangle of length 3 centimeters and breadth 2 centimeters. The longer side is called length, the shorter side is called as breadth. It is of 3 centimeters. So how many 3 centimeters will be there? 1, 2. So you can divide how many centimeters this? 3. So hence you can, this is 1, 2. This is 1, 2, 3. Since it is a 3 centimeters, so you can divide this into 3. So the formula for area of rectangle is area of rectangle is equal to length into breadth. Length into breadth. What is the length? 3 into what is the breadth? 2. So is equal 3 into 2, 6 centimeter square. 6 centimeter square. Let us write the units also. So the length is 3 centimeters and the breadth is 2 centimeters. 3 2s are 6. Centimeter into centimeter, centimeter square. 3 into 2, 6. Centimeter into centimeter, centimeter square. So what you have got? 6 centimeter square. What that implies? 6 into 1 centimeter square. How many 1 centimeters boxes will be available here? 6. So if you divide this also, see 1, 2, 3, 4, 5, 6. So this is the formula for calculating area of rectangle. You will calculate like this. So but here what this area indicates, how many 1 centimeter boxes are there, how many 1 square centimeter boxes are there. So this is the concept of area. So now for a regular shapes, for a rectangle, for a square, for a triangle, parallelogram, for a circle, to find the area there will be some formulas. But if there are some irregular areas are there, if you want to measure the areas of the irregular shapes, so let us take a leaf. So I have considered a leaf. So how can you measure the area of this irregular shape? So this is in the shape of irregular shape. Regular shapes means rectangle, triangles, regular shape, irregular shape. So rectangle, square, triangle, circle, parallelogram, trapezium. So these are the different regular shapes. To find the areas of these regular shapes, you will have some formulas. But how can you find the area of an irregular shape? So you have seen the formula of area of the rectangle LB and the area of the square is L square. So like that, for different shapes you will have some formulas. But to measure the area of irregular shapes, what will be the formula? No, there will be no formulas for measuring the irregular areas, irregular shape areas. So how can we measure that? So let us see how can we measure the shape of an irregular object. So measuring area of irregular object. Measuring area of a irregular object. Measuring area of a irregular object. How can you measure the area of an irregular object? So in the previous session we have learned how we have measured the length of a curved line. We have used thread. So similarly, to measure the area of an irregular object, we can use the graph paper. We can use the graph paper. If you observe the graph paper complete sheet is divided into square boxes. The complete sheet is divided into square boxes. So let us say this is the graph paper. The graph paper looks like this. So the complete sheet of graph sheet, the complete graph paper is consists of, the complete graph paper is divided into some square boxes, and let us say this is the square box of 1 centimeter square. This is the square box of 1 centimeter square, and again in this square box small boxes will be there. Again this box is divided into some millimeter square boxes. So how many boxes will be there? If you count these boxes, 100 boxes will be there. 100 boxes will be there, and each of length 1 millimeter square. That's why we will say this as 100 millimeter square. 100 millimeter square. So 100 millimeter square is equal to 1 centimeter square. It is a 1 centimeter square box, right? So let us find out that 1 centimeter square is equal to how many millimeter square? How many millimeter square? So you can write this 1 centimeter square as 1 centimeter into 1 centimeter. Can you write like this? Yes. 1 into 1, 1. Centimeter into centimeter, centimeter square. You can write like that. So 1 into 1. So 1 centimeter is equal to how many millimeters? 10 millimeters into, again 1 centimeter is equal to 10 millimeters is equal, 10 into 10 is 100 millimeter square. 1 centimeter square is equal to 100 millimeter square. So here you can find a small box of area 1 millimeter square. How many boxes will be there? So in a 1 centimeter square of box, 100 millimeter square boxes will be there. In an area of 1 centimeter square, 100 millimeter square boxes are there. So like that, the graph paper is completely divided into some square blocks. So if you want to measure the area of an irregular object, let us consider an irregular object. We have considered a graph paper. We have considered a graph paper, and an irregular object is considered let us consider a leaf. So consider a leaf. We want to measure the area of the leaf. Place the leaf on the graph paper. Place the leaf on the graph paper. So place the leaf on the graph paper. So I have placed the leaf on the graph paper. So I think you were observing. So after placing the leaf, place the leaf on the graph paper and draw the borders of the leaf. Draw the borders of the leaf on the graph paper. Draw the borders of the leaf on the graph paper. Now remove the leaf. Now remove the leaf. So now remove the leaf and count the, now remove the leaf and count how many number of boxes are there. How many number of small boxes are there. So how many number of small boxes are there, and that number will give the area of this leaf, and that number will give the area of that leaf. So in this way, let us write the procedure. What is the procedure? Place the leaf on a graph sheet. Place the leaf on a graph sheet. Draw the borders of leaf. Now remove the leaf. Now remove the leaf and count the number of boxes. Count the number of boxes inside the border. Inside the border. So you have drawn a border for the leaf, and you have to, after removing the leaf, you need to count how many small boxes is there. So you have to count all the boxes. So after counting, you will get, so the number of boxes will be equal to the number of boxes gives area of leaf. Gives area of leaf. So in this way you can find the area of an irregular object. Area of an irregular object. So let us discuss about volume. So what is area? This area is a measure of extent of place occupied by an object, place occupied by an object on a plane surface. Whereas the volume is also similar definition, but a small difference is there. So let us see that. Volume. So volume is a measure of extent of space occupied by an object. Occupied by an object. So what is the difference you have noticed between the definition of area and volume? So in the definition of area, you extent of plane surface occupied. So here it is the area is the space occupied on a plane surface, whereas volume is the space occupied by the object. So this particular object is occupying some space in the three-dimensional view. It is occupying some place, whereas the object occupying on the plane is called as area, and the occupied space by this object is called as volume. The object, if you place the object here, the object is occupying some place on this plane surface, and this object is also occupying space, not only on the plane surface, it is occupying some place in this direction also here. So it is occupying some space. So that is called as volume. Volume is the space occupied by the object. I was occupied some space in this room. I was occupied by some space in the room. So it is the volume. My foot was occupied some place on the floor. Area is the place occupied on a plane. Area is the space occupied on plane. Whereas plane means it may be floor or any pads or any boards. These are the planes. Whereas volume is the place occupied in the space, in the room, the total space occupied by the object is called as volume. So let us understand about some volume. So let us construct a cube, a three-dimensional object with 1 centimeter of length. I have constructed a cube with 1 centimeter of length. So what we will call this as cube. This is cube constructed with 1 centimeter of length. So every side is 1 centimeter. Every side is 1 centimeter. And this volume of this cube is called is 1 square cubes, 1 centimeter cube, 1 centimeter, 1 centimeter cube. It is a cube, it is not a square, it is a cube. So if it is square, we will denote power 2. So since it is a cube, we will denote this as 1 centimeter cube. Power will be 3. If it is square, you have to write power 2. What is meant by power 3? 1 centimeter cube is nothing but 1 centimeter into, in sense it is 3, power 3, centimeter into centimeter into centimeter. So centimeter into centimeter into centimeter is nothing but centimeter cube. So this is 1 centimeter cube is the standard unit for measuring volume. For example, let us consider a cube. So let us consider a cube of 2 centimeters, of length 2 centimeters and height 2 centimeters and breadth 2 centimeters. So otherwise it is better to consider a cuboid. Cuboid means this shape is called as cuboid. So let us take this length as 3 centimeters. So let us take a cuboid. So this is the length is 3 centimeters. Let us say this length as 3 centimeters and this length as 2 centimeters. This is 3, this is 2 and this is 1. Let us take like that. 2 centimeters. Then you can call this as cuboid. This shape is called as cuboid. So to measure the volume of cuboid, there is a formula. Volume of cuboid is equal to length into breadth into height. Volume of the cuboid is equal to length into breadth into height. So what is the length we have considered? 3 centimeters. 3 centimeters into, what is the breadth? 2 centimeters into, what is the height? 1 centimeter. So 3 2s are 6, 6 1s are 6. Centimeter into centimeter into centimeter, centimeter cube. What does that mean? So this particular cuboid will consist of, see here we have got 6 centimeter cube. What does that mean? It is, you can write this as 6 into 1 centimeter cube. 6 into 1 centimeter cube. That means in this particular cuboid shape, you can insert 1 centimeter cube boxes. 1 centimeter cube boxes. How many 1 centimeter cube boxes will be there? 6 will be there. What is the meaning of 6 centimeter cube? 6 centimeter cube? 6, you can write this as 6 into 1 centimeter cube. That means 1 centimeter cube boxes will be there. How many will be there inside it? 6. So in this way, this is about the concept of volume. For example, liquids will also occupy some volume. How can we measure the volume occupied by a liquid? So there are some measuring jars. To measure the volume of a liquid, we will use a measuring jars. So a measuring jar is a cylindrical shaped container. There are some readings will be given here, will be mounted on the walls of the container. So this is a measuring jar. Measuring jar. So it is a glass made jar. It is a material made with glass. So if you want to measure the volume of the liquid, if you want to measure the volume of the liquid, you has to pour the liquid in it. You has to pour the liquid in this measuring jar. So where the level of the liquid coincides with the reading, so from this, where the level is, where the surface of the liquid coincides with the reading will gives the volume of the liquid. So measuring jar mostly the measuring jars will be available in the shape of a cylindrical vessels, and if you want to measure the volume of the liquid, you has to pour the liquid into the glass cylinder jar, and the level of the surface level at which the surface level shows readings in the measuring jar. So there are some readings present on the walls of the measuring jar. So the surface level will indicate the readings of the volume of that liquid. So in this way you can measure the volume of the liquid. So with this we have learned about how can we measure the length, area and volume. With this the lesson was completed. Thank you.